So today I'm going to talk to you about the future of electronic clothing. I'm going to start off by showing you Sweden's two largest companies on the stock market. You all know what companies these are. It's Ericsson and H&M. And obviously Ericsson is in the information technology business, whereas H&M is in the clothing business. Even though they're so huge, their products are actually completely separated from each other. And the reason for this is that ICT and textile industries have not merged yet, although there have been so many advances in the ICT industry lately. Looking at the evolution of information technology as to answer the question of why this merger has not happened, as you know, the whole thing with IT started with the invention of components and, in particular, the transistor, which was based on metals and quite solid stuff. They were quite large, but then there was the revolution of integrated circuits. Today you can make many transistors on a very tiny area. But still, in a sense, the whole concept of large components and packaging large components and mounting them lives on. So, this is a very modern electronic circuit. It's, I think, a BlackBerry smartphone. Very advanced IT piece of product, and it is still based on the fact that you use components and mount them on a printed circuit board. And obviously, the machinery and everything that does this is extremely advanced, and they can be mass produced with huge precision and very low cost. So why would you like to change that? Well, if you can merge textiles and electronics, you will overcome a lot of obstacles that exist in terms of the way that things are packaged today. For example, electronics are not flexible because of the way they're constructed today, like mobile phones. There are limitations to designs. There are limitations to the area that you can make them. And also there are limitations to the toughness and the friendliness of electronics, which are not there in textile. So, what methods are there today and will there be to merge these huge industries and have new products in the future? Well, the most obvious way to approach this is, of course, to look at the PCB, the printed circuit boards, that today are at the heart of our electronics. PCBs are just a platform for mounting components, and really all the structures that are on the PCB are quite large. The only aim they have is to support the components and to conduct electricity, connect the components together. So just by using a weave and with fibers that conduct electricity, you could actually basically replace the PCB with a cloth. And there are already a number of commercial examples of fibers that conduct electricity. Then if we also look at the components today, the integrated circuits, they're actually can be very small, although they're advanced, and they're very cheap. And in a sense, the size is already the size of a single fiber. So it's more a question of packaging and connecting a fiber to a component at a purely engineering point of view, which limits the way that, or limits the way electronic textiles can be made today. And if you really think of these two approaches with replacing a PCB with textile and connecting fibers to very small components, you already can achieve electronic circuits or electronic products that are in textiles. And I've actually taken with me an example that I've made myself. First of all, what I want to show you this is that there is no metal in this one. No metal at all. Everything is completely fiber, except for the components. But they're so small that you cannot feel them. So immediately, you start to see things, the way they react, which you are not used to from conventional electronics, just by making these hybrids. For example, you're not used to being able to treat electronics like this, because you're used to electronics being very stiff and fragile. But by just taking textile into account, you can already see that that changes, and already this gives rise to a huge number of opportunities for making new electronic products. And just looking one step further, of course, if one can have components that are somehow integrated into the fiber from the beginning when textile fibers are made, then we're talking about something which is called fibertronics. And there are a number of research examples where fibertronics is being made in the lab today. Here is an example of a light emitting device which is made on fiber. We have here at Linköping University also showed actually that we can make transistors directly on fibers based on conducting plastics. So this is actually a real picture of transistors, where these yellow dots are transistors on nylon with some conducting electricity. And once you have fibers that carry these components and they're produced on a mass scale, it's easy to conceive that although you cannot reach the same nano dimensions as you can do with integrated circuits, you can achieve a huge number of components. Let's say on a meter of textile, you could have millions of components because they're already in the fiber, and once you weave them, it automatically is there. You have millions of components on a textile fiber. And since they're embedded, the flexibility would be one step even more than what you see here. They would completely feel like textile, but there would be millions of components in textiles. So the opportunities to what you can do with these types of products are beyond our imagination today. And I think we have a very, very bright future here between the merger of these two industries. So I leave you with that, and thank you.